Hello everyone. So today is the second lecture on the chapter statistics. In the previous lecture, we had talked about why the measure of variation is important, and we have talked about some measures of variation like range and mean deviation. So in mean deviation, we talked about discrete frequency distribution. Today we'll see how we tackle continuous frequency distribution, and this mean deviation we also talked about. It can be calculated about the mean and also about the median. In fact, it can be calculated about any value, but generally mean and median are taken to calculate mean deviation. So first, we will revise what is mean deviation. Okay. So mean deviation is a measure of dispersion that calculates the average distance of each point from the mean of a data set. So this mean, it may be any point. It may not only be the mean. Okay, and we write mean deviation as MD bracket A. And this A can be any value. It can be about the mean, it can be about median, or it can be about any other value you want. And we express it in using this expression. So we have seen mean deviation for ungrouped data in the previous lecture, and we have also seen mean deviation for group data. For group data, we have talked about a discrete frequency distribution case. Now we will see for the continuous distribution case. Okay. So what is continuous frequency distribution? First, we'll understand what is a continuous frequency distribution before we move on to see how mean deviation is calculated for continuous frequency distribution. So continuous frequency distribution is a way to organize data into intervals or classes along with their respective frequency. So when you see an example, you will understand what this means clearly. It just says that we are organizing data in intervals. So suppose you have an income slab. Like previous day, we saw an example of income slab from 1 lakh to 1 crore. And we are saying that suppose 1 lakh to 2 lakh, there are 2000 people here. From 2 lakh to 3 lakh, there are 5000 people here, and so on. So this is an example of continuous frequency distribution. We are dividing it in intervals or classes. From 1 lakh to 2 lakh is a class. From 2 lakh to 3 lakh is a class. Okay, and so on. So these classes have some frequency. Frequency means how many observations are being taken in between these classes. It is used when the data values are not discrete and fall into range or continuous continuum of values. So here in this example which I have stated, you can clearly see that any value, suppose you are in the salary range of 2,50,000 annually. So this 2,50,000 will come in this range from 2 lakh to 3 lakh, and this data will be taken as a frequency for this range 2 lakh to 3 lakh. So the class of intervals is a continuous frequency distribution and do not have any gaps between them and are continuous. You can see there is no gap between them. There is no discrete points. Everything is continuous. So all values between 2 lakh and 3 lakh will fall in between these two range, right? Similarly, all values between 1 lakh and 2 lakh will fall in between these two range. The last point here says that the frequency in each class interval represents the number of observations that fall within the class interval. So I hope you know this. I'll again inform you what this means. It says that when we are saying that 5000 is the frequency of people having income between 2 lakh to 3 lakh, it means that 5000 observations. So suppose we are doing an experiment and 5000 people have salary between 2 lakh and 3 lakh. So this frequency says that this range, we have got this number of observations. So 5000 observations has been made between this range 2 lakh to 3 lakh. Okay. So one more example I have given here. It says that we are doing a experiment and we have data of height of 100 people. So we have 100 people here and we are doing an experiment for the height. So you know that height can be expressed in continuous manner. So someone's height can be 153 centimeter. Someone's height can be 153.3 centimeter. Someone's height can be 163.25 centimeters. So this is a continuous range. So suppose we have a continuous range of heights and it is saying that ranging from 150 centimeter to 190 centimeter. So we can divide this range. So 150 to 160, 160 to 170, 170 to 180, and 180 to 190. And the class interval, so we can create intervals of say 10 centimeter each as follows. So 150 to 159 centimeter has 5 people in it. So we are saying that you can also write this as 160. You can also write this as 170. So what will be the problem if you write 160 is that you have to specify if this 160 fall in this range or 160 fall in this range. To overcome this challenge, I have divided it by 150 to 159, 160 to 169, 170 to 179, 180 to 189, and 190 to 199. You could write 160. So you could write this as 150 to 160, 160 to 170, 170 to 180, 180 to 190, and 190 to 200, right? But in that case, you would have to specify which class this 160 fall, right? Or 170 fall. If it falls here or if it falls here. That's what to overcome this challenge, I have divided it like this. Now, what does this data say? So it goes on to 199. So I'll write 190 and 200. Okay. So what does this data say? It says that 5 people are between 150 to 159. So here we have 5 people. 160 to 169, we have 20 people. 170 to 179, we have 45 people. 180 to 189, we have 25 people, and 190 to 199, we have 5 people. Okay. So this is a frequency distribution. And you may have read in the previous classes that we can draw this using a histogram. So from 160, 150 to 160, you can draw a histogram with height 5. From 160 to 170, you can draw a histogram of height 20. From 170 to 180, you can draw a histogram of 45 with height 45. Again, from 180 to 190, you can draw a histogram of height 25. And from 190 to 200, you can draw a histogram of height 5. So this this represents the distribution of height in between the range 150 to 120. You can see that it is a continuous distribution. So all the height between 150 to 160 have fallen between this range, and there are 5 people. So generally what we do is we assume that the middle point is the mean of this range, and then we calculate the mean deviation. You will see this in next slide. So in this slide, I am just talking about what is a continuous frequency distribution and how frequency distribution are given to continuous range. So this is how we visualize the data of frequency distribution in continuous cases. So I have given 2 examples. First, I have given the example of salaries, and the second, I have given the example of height of people. Okay. So we'll talk about mean deviation about mean for the continuous frequency cases. So first we're talking about the mean. So we will know how to calculate the mean for a continuous distribution case, and then we'll go on to see how mean deviation is calculated about the mean for continuous frequency distribution. So this is very important. Okay. It says that we are assuming that the frequency in each class is centered at its midpoint. So in the previous slide, I have told you that we take the midpoint of 150 to 160. This, and we are assuming the frequency 5 is centered about the midpoint. So this will be 155. So 5 is centered about 155. This is an assumption we are making. Similarly, this 20 is centered about the midpoint 165. Okay. So we are saying that the frequencies of each class is centered about its midpoint. And what we will do with this midpoint, we take this and we write the midpoint of each class and proceed for the frequency distribution case in the discrete case. and then we calculate the mean deviation. So it is similar to what we have done in the discrete frequency distribution case. The only change is for each xi, we are taking the midpoint for each xi. So for calculation of mean also, we had this formula mean x bar is equals to summation of I equals to 1 to n xi times fi by summation of I equals to 1 to n fi. So this xi for discrete cases, we had values, but for continuous cases, we are taking the mean value, sorry, mid value of the range. To calculate the mean deviation also, we had this formula, and this xi will be the mid value of the continuous frequency distribution. So for this example, x1 will be 155. So this value 155, x2 will be 165, x3 will be 175, x4 will be 185, x5 will be 195. Okay, and for this we use the same formula which we have used for the discrete frequency case. I'm writing the formula again. So md of x, because we are calculating for the mean value x. It is given as the summation of I equals to 1 to n frequency fi into the deviation of xi from the mean, because we are calculating it from the mean, by summation of I equals to 1 to n fi. And this summation equals to summation of fi's is actually the n, the number of observations we are taking for the experiment, or the number of data sets we have. In this case, in the earlier case, we had 100 as the number of data sets. Capital N is 100 for this case. Okay. So we have seen how to calculate for the continuous frequency distributions by taking the midpoint. So we'll see one example. So suppose we have a class and there are 40 students in the class and this is the score. So from 10 to 20, there is one student who has scored this marks from 10 to 20. 5 students scored between 20 to 30. 4 students scored between 30 to 40. 6 students scored between 40 to 50. 9 students from 50 to 60. 7 students from 60 to 70. 5 from 70 to 80. And 3 from 80 to 90. So these are the frequency distribution of marks of a class with 40 students. Now remember what we told you? We told you that we should take the midpoint of this range, and we are saying that this frequency is centered about this midpoint. So for each class we will take the midpoint. So from 10 to 20 we are taking 15, and from 20 to 30 we are taking it as 25. So now you see 20 is in both the range, 30 is in both the range. So we have to specify whether to 20 to 10 to 20, will it 20 goes here or 20 goes here. So for this case, we are assuming that 10 is included here, but 20 is not. This we are assuming that 20 is included here, but 30 is not. We are just writing it differently. Okay. So we have taken the midpoint of each 35, 45, 55, 65, 75, and 85. Now we'll proceed as usual. What we did, we calculated fi times xi. So we'll multiply 1 into 15, which is 15, 5 into 25, 125, and so on. So we'll multiply these two, fi and xi. So this xi is the midpoint. Okay. So go to this formula. For calculation of the mean, we need this summation of xi into fi. So we have fi into xi, we will do the sum. This sum comes out to be 230. And for calculation of the mean, we had summation of xi fi or fi xi by summation of fi. Okay. So we have summation of fi. This is actually summation of fi for number of students in the class, 40. So for mean, we divide 2130 or this sum by the number of students in the class. So the mean we got at is 53.25. This is the mean of the marks of the students in the class. Now we calculate the deviations. So deviations is given as, or absolute deviations, modulus of xi minus x bar. So x bar is 53.25 we take the difference and do the absolute value. So these are the absolute values of deviations, right? So in the calculation of mean deviation, we had summation of fi times the absolute deviation by summation of fi. So we have summation of fi as 40. We just need the numerator. So we have calculated deviations, absolute deviations. We'll multiply this frequency with the deviation. Okay. So we are doing it here. So we're getting 1 into 38.25, this value, 5 into 28.25, this value, and so on. And then we calculate the sum. So this sum is actually summation of fi times xi minus x bar. This is the sum. And for MD, we will do this by, so 604 by 40. So we'll get 15.15 as the mean deviation about the mean. Okay. So you see in this example, we are doing the same thing what we did for discrete frequency distribution. The only change we have is that one more extra column we need to calculate, which is the midpoint column. When you have this midpoint column, it is exactly the same as what we did for discrete frequency distribution. We multiplied this fi with this midpoint and we took the deviation of each midpoint from the mean. Okay. And for calculation of the mean also we used this midpoint values. Okay, so this is only extra. Everything is the same. You go back to the previous lecture and you check that everything is the same, only we have to calculate the midpoint. Okay, so in the previous slide we saw that how we have done mean deviation about the mean, but this multiplication of these two and then getting the sum, which is a big number, 2130, and then calculating the mean, it is tedious. And we have a shortcut way to calculate the mean. If we could calculate the mean easily, then calculation of absolute deviation will be a little bit easy. So we'll see in the next slide how to calculate mean in a shortcut method. So shortcut method for calculate the mean deviation about the mean. So this method is known as step deviation method. Okay. So how this helps? It is used to avoid the tedious calculation of computation of x bar. What is x bar? Mean. So it helps to calculate the mean easily. You see, each xi can be written as x bar plus the deviation di. Okay. And we have not taken absolute deviation. It is just the deviation di. Okay. This is not absolute deviation. It is just the deviation. Now, if we have this di for each value, there is a common factor. So suppose for deviation of first, it is 20, the second it is 10, the third it is 0, the fourth it is 30, and so on. So you see there is a common factor of 10. So you can say the first is deviated by 2 steps, the second is deviated by 1 step, the third is deviated by 0 step, the fourth is deviated by 3 steps. So there is a common factor 10 in all these deviations. Similarly, if these di, capital Di has a common factor, so you can take that factor out and you can write di. So for 20 deviation, you can write 2 into 10. For 10 deviation, so these are di, this is small di and this is h. Okay. For 10, you can write 1 into 10. For 0, you can write 0 into 10. For 30, you can write 3 into 10. You can take negative values also. So minus 60 if you have, you can write minus 6 into 10. Okay. So these di's are the step deviations. These are step deviations. Okay. So this is known as step deviations. And this is why this step is known as step deviation method. Now you see, you can have these step deviations with this formula. What you do is you assume that you know the mean A. You have some data. You actually don't know the mean. You are trying to calculate the mean. So you assume that the mean of the data is A. And for each data point xi, you calculate the deviations. So you do xi minus the mean by h. We are doing the same thing essentially. You see x bar xi minus x bar, from here it is, you see, by h is equals to di, right? So similarly, you're doing the same thing here also. This is di. Di is equals to x bar minus a by h. Okay, where a is the assumed mean. Now, to calculate the mean by step deviation method, all you have to do is x bar is equals to a plus summation of fi di by n into h, where this h is the common factor and n is the number of data points. So this formula helps to calculate mean in an easier way. Okay, so let's visualize what is happening. So suppose you have a data, it's starting from 0. So 0, then 10, 20, 30, 40, 50, 60, 70, 80. Suppose you have this data and you are saying that 40 is the mean of the data. Okay. So what is the deviation of 40? So suppose you are saying that A equals to 40. So from 40, you have data at each point of the 0, 10, 20, each point you have one data. Okay. And you are saying 40 is the mean of the data. So for this, we are shifting the origin. So if this is the origin, we are shifting the origin to this point. Okay. So we'll say 40 minus 40, this is 0 deviation. Then 30 minus 40, which is minus 10 deviation. 20 minus 40 is minus 20, then minus 30, and then minus 40. Okay, for each point. Similarly, here we have 50 minus 40 is 10, 60 minus 40 is 20, 70 minus 40 is 30, and 80 minus 40 is 40. So from the mean, from the assumed mean, this first data is 10 distance away. What is this value is saying? It is the saying that from this assumed mean, this data is 10 distance away. This is 20 distance away. This is 30 distance away. And this is 40 distance away. Okay, 30, 40, 20. Similarly, this side also minus 10, minus 20, and so on. Minus 30 and minus 40. So you have calculated the deviations. Now you see for these deviations, di, you see they have a common factor of h is equals to 10. So what will be small di? It will be minus 4, minus 3, minus 2, minus 10, 0, sorry, minus 1. 1, 2, 3, and 4. Okay. So you are saying that these are the steps. So 1 step, 2 step, 3 step, 4 step. What is 4 step? 4 step of 10, right? 4 step of 10 is 40. Similarly, minus 1 step, minus 2 step, minus 3 step, and minus 4 step. So if you are saying minus 3 step of what? Minus 3 step of 10, which is minus 30. So this data, let me change the color for more clarity. This data is minus 3 steps of 10 away from the assumed mean A. Okay. So it is minus 30 distance away from the assumed mean A. Right. So this is what we are doing. And from this, we are calculating the mean, which is saying that x bar is equals to A plus summation of fi times xi by n into h. Okay. You know A, you know h, it will be di. And you know di because you have the value di. Okay. You have for each value, we have di. Now let's see an example how we are doing it. Suppose we have a continuous Achha. What I have done here is we have done one example here and we calculated the mean deviation as 15.1. Now you see whichever step you take or whichever way you calculate the mean deviation, this mean deviation will remain the same. Why? Because the data is the same. The data doesn't change. This is the data. and this data doesn't change, it is the same. So whatever step you take or whatever way you calculate the mean deviation, this mean deviation will remain the same. So in this case, we have just calculated using a normal method. But if we apply the step deviation method, which help us easily calculate the mean, we will get the same mean deviation. In this example, you see, we will go through the steps, but you see first, is this mean deviation is same, 15.15. Why? Because the data is the same. This data is same as the previous table. So the marks of the students are given 10 to 20, 20 to 30, and the frequency is also given 1, 5, 4, and they are the same as the previous example 1, 5, 4, 6, 9, and so on. You see, everything is the same. We are just doing this, or we are just calculating the mean deviation using step deviation method. So how we go on to do the step deviation method? So suppose you have this data, the marks of the students and frequency of each range. So you assume a mean. Here I have assumed to be 50. You just assume any value which is in between the range. So from 100 to 90, sorry, from 10 to 90, you assume a middle value which you feel is the middle value. So I have taken it to be 50. You can take it as 45 also. You can take it as 40 also. Whatever value is you take, it will work. But you have to take into account that this value should be in the middle. If you don't do that, then the calculations will not be as simplified as in this table. So if you take very close value to the original mean, so if the original mean is suppose, so we have the original mean is 53.25. So as close as you take this assumed mean, the calculations for these and these will be easy. So here I have taken it to be 50. We don't know. Remember, we don't know this value from the starting. We are trying to calculate the mean. To calculate the mean, we have assumed that any middle value to be as the assumed mean. So I have assumed 50. And then I have seen that this data and the deviation of each data from the midpoint. So the midpoint for first data is 15, the second data is 25, 35, 45, 55, and so on. So I'm assuming that h is 10. Okay. You can take simple numbers like 5 or 10. So this will make your calculations easy. So here I have taken it as 10. So what I am doing, I am just, we have the middle value, and then from this assumed mean, I am taking the difference. So you have the formula for di, right? So di is equals to xi. You can see here di is equals to xi minus a by h. So di is equals to xi minus a by h. So you have xi's, these middle values are xi's. So for the first value it is 15, a is 50 by h is 10. So this is coming out to be minus 35 by 10 or minus 3.5, and this is what I have written here, right? So for each value you do the same. For the second value it will be minus 2.5. For the third value it will be minus 1.5. For the fourth value it will be minus 0.5, then 0.5, then 1.5, then 2.5, and then 3.5. So for each value you calculate di. But if you see in the earlier slide, we are not calculating di, right? So these are, you have to take care what you have to calculate in each table, and that will make your steps easy. So here we have calculated di. Now instead of fi times xi, we will calculate fi times di. Okay, so we are multiplying this di by fi. So 1 times this, 5 times this, and so on. For each value we are multiplying fi into di and then taking the sum. Okay, and we know the formula for mean is x bar is equals to x. Let me change the color. So we know that x bar is equals to a plus summation of fi di by n into h. So here A is 50 times this sum is actually summation of FIDI. Summation of FIDI you have calculated as 30. What is the sum? This sum you are taking, these values you are taking. So you see, you have some help. You can see this 12.5 minus 12.5 and plus 12.5 get cancelled out and so on. So in this step, you will have some negative values and this will help your calculation. This, you see, the sum is only 13. In the previous table, the sum went up to 2130. So this makes your calculations easy. The calculation of mean is becoming easy. You're taking the sum and it is coming out to be 13. And then you divide it by 40 and then you get this number 53 point. You divide it by 40 and then you multiply it by h. Here you have to multiply it by h, which is 10. This will be come out to be 53.25. And this is it. The step deviation method is only to calculate the mean. The next step of the table is same as what we did earlier. You see this mean 53.25 is same as the earlier mean 53.25, right? Now next step is same. So you have this x bar, you have calculated this x bar. So this x bar is here. Now you calculate the mean deviation of each midpoint, these values. So 15 minus 53.25 modulus, which is 38.25. And each value from the table you do the same. Okay. From these values 15, 25, 35, 45, 55, and these values you take the absolute deviation from the mean, which is 53.25. Now what is the next step? You multiply it by the frequency. Each value you multiply it with the frequency. So you're multiplying the first frequency, which is 1 with this 38.25, then 5 with this 28.25, and you calculate these values. Okay. And then you take this sum for mean deviation. So this sum is what? This sum is summation of Fi times Xi minus X bar. This sum is this. And for mean deviation, you divide this by n. Here n is 40. So you will get the mean deviation, and you see this is same as the previous table 15.15. Now I have given a note here which is important. It says that the step deviation method is applied to calculate X bar. The rest the procedure is the same. So only to calculate X bar this method is used. Okay. The other procedure is same. Whatever we did for earlier slide where we calculated the mean deviation for continuous frequency distribution, we are doing the same. Only to calculate the mean X bar, this step deviation method is used. Actually, it helps to calculate the mean. It simplifies the process of calculating the mean. So remember the steps. First, you take a assumed mean A, then you take a factor H, and then you calculate these DIs. And then you apply this formula. X bar is equals to A plus summation of FIDI by N times H. Okay. So this is how we calculate. So what I would request you is, you take this data again, marks and frequency, you take this data and you write this table again in your copy. Do it on your own. First you calculate the midpoint, then you calculate DI, then you calculate FIDI, and then you calculate the absolute deviation, and then you multiply it by the frequency and calculate the mean deviation. You should get the same value. In this way, you will, when you practice, you will know what are the steps to calculate the mean deviation. Okay. So I hope you understand what is step deviation method and how it helps to calculate the mean. So both the methods, the earlier one, this one, and the step deviation method is doing the same thing. Only step deviation methods help to calculate the mean in an easier way. Now we will talk about mean deviation about median. Okay, how to calculate mean deviation about median. Remember, we talked about how mean deviation can calculated about any value. Either it can be the mean, or it can be the median, or it can be any other value. So we have seen how we calculate about the mean. Now we'll see how we calculate about the median. So for mean deviation about median, for continuous frequency distribution can be calculated using the same formula as the mean deviation about mean. So whatever formula we used for mean, we do the same thing for median also. But the difference is how we calculate the median. Median is used to measure the central tendency. So this calculation of median is only changing. Everything else is remaining the same. So mean deviation about median will be given as summation of fi times xi minus capital M by summation of fi. Only how to calculate this median is important for continuous frequency distribution. So we will see this with an example. Then how are we calculating this median? Okay. For discrete frequency distribution, it is very simple. You take the ascending order and you take the middle value. Okay. I hope you are understanding what I mean by middle value. It is not exactly the middle value, but I hope you know what is median. So to calculate the mean deviation about the median, first we need to find out the median of the continuous frequency distribution. This calculation of median for continuous frequency distribution is what different from discrete frequency distribution. When we calculate this median, what we do is we subtract each value of the distribution from the median and take the absolute value of the difference. Okay. Then we multiply each deviation with its corresponding frequency. We multiply it with this frequency. And finally, we add up all the products and divide by the total frequency and get the mean deviation about median. So this is the formula what it is talking about. Okay. Now you see for continuous frequency distribution, so each value is actually the middle value, mid value. Here also we did the same thing. We took the mid value. Why are we doing it? Because we are assuming what did we write right here? We are assuming that the frequency in each class is centered about its midpoint. This is very important. Okay. We are assuming that the frequency of each class is centered about its midpoint. This is why we are calculating the midpoint. This mid value. Okay. So we'll see one example how to calculate the mean deviation of the about median of the data about median. So you see this is the formula to calculate median for continuous frequency distribution. So m is equals to small l plus this n by 2 minus c by f into h. So you may get confused what this is, but this is not very difficult. You see, first we'll talk about what this expression means. So first L. So L says lower limit. So what is lower limit? So suppose you have some data 10 to 20, 20 to 30, 30 to 40, 40 to 50 and so on. And suppose you have frequencies for each distribution like 2, 4, 7 and 3. So now you calculate the cumulative frequency. So first will be 2, then 6, then 13, then 16. Okay. And suppose you have one more data 50 to 60 as 3, 19. Okay. Now you take the middle value. So 19 you will have 10 as the middle value. So you see 10 will fall here because 6 is here, 10 is falling somewhere here. So you take the lower value, which is 30. So if you plot the here you plot the cumulative frequency and here you plot the distribution 10, 20, or you can do the opposite also. You can plot the cumulative frequency here and the distribution there. That doesn't matter. 30, 40, 50 and 60. So you see you have 2, 6, then 13, then 16. So you want 10. So it is somewhere in between, right? Somewhere in between. So what you are doing is you are taking this value and you are trying to see what value corresponds to this value. You are trying to get this value. extrapolating it. Okay, so you take L as the lower limit of the distribution, which is 30 here. Then you do n by 2. Okay, so for 19, n by 2 is 9.5. Okay, and this C, what this C is, it says that the cumulative frequency of the class just preceding the median class. So what is the cumulative frequency just preceding the median class? Here the C is 6. So for this example, L is actually 30, N by 2 is 9.5, C is actually 6. Now F is the frequency of the class. So frequency of the class is 7, and H is the width of the median class. So what is the width of the median class? Here 10, right? 30 to 40, 10. So when you calculate this value, you will get the median of this data. And this is how we calculate and this is how we calculate the median of a continuous frequency distribution. Okay, so this is how we calculate the median of a continuous frequency distribution. You use this formula. So again, I am saying what is L? L is the lower limit, which is 30 here. How we are knowing 30 is the lower limit? So first you see what is N? N is 19. N is 19. You do N by 2, 9.5. You see in the cumulative frequency case where this 9.5 is lying, it will lie in between these two, right? More than 6 and less than 13. So it will lie in this row. What is the lower limit of this row? It is 30. So L is 30. Then you take N by 2, which I have written at 9 by 5, 9.5. You take C. What is C? The cumulative frequency just above this median class, which is 6 here. So you write 6. Now F is the frequency distribution of frequency of that class, which is 7 here. And then you multiply it by the width of the frequency class. Okay, median class, which is 10, and you calculate the median. So when you calculate the median, rest step is the same. You just calculate the deviation of each data from the median, and then you calculate the sum of the multiplication of the frequency into the absolute deviation. So we are doing the same with an example in here. When you perform this example on your own, when you practice this example, then you will see it is not difficult. All steps are the same. Only calculation of this M is where we are changing. The problems are changing in one another or different from one another. So I'm taking an example here where N is 40, and actually I think it is the same example as the previous one. So the data is same, the marks of class from 10 to 90, and we have the same frequency 1, 5, 4, 6, 9. Same frequency is there. So you can see that it is the same frequency, right? Same frequency. Now only difference is we are calculating the mean deviation about median. Earlier what we were doing? We were doing mean deviation about the mean. Therefore, this value is not the same as the previous value. Earlier we were getting 15.1. Why? Because we were doing the deviation from mean and not median. So here we will do it from the median. So first we calculate the median of the class. So you see N is 40. So N by 2 will be 20. So where will 20 lie? For that we have to see the cumulative frequency distribution. So see, it will be above 16 and below 25. So this is the median class. Okay. This is the median class. So what is the lower limit of this median class? It is 50. You see the lower limit of the median class is 50, and N by 2 we already know it is 20. So what is C of the class just above the median class cumulative frequency? C will be 16. Okay. And F, the frequency of the median class. The frequency of the median class is 9. Then you have to calculate H. What is H? H is the width of the median class. What is the width of the median class? 60 minus 50, which is 10. So you can calculate M easily. Everything is given. You just calculate M. M is L, which is 50 plus 20 minus 16 by 9 into 10, which will come out to be 54.44. So the median of this data is 54.44. After that, everything is the same. You see, after this, everything is the same. You calculate the midpoint. What is the midpoint of first data? 15. Second data, it is 25. Third data, it is 35, and so on. You calculate the midpoint of each data. Now, you take the absolute deviation. Absolute deviation. So this is the absolute deviation. So you see, we are doing this median is 54.44. We subtract, so 15 minus 54.44 and take the absolute value. Okay. So this is what this is. This is modulus of 15 minus 54.44, which is coming out to be 39.44. See, this is this. And so on, we calculate for each value. Okay. Now we multiply the frequency with the absolute deviation. So we get this table. So the first data is multiplied by 1, the second data is multiplied by 5, the third data is multiplied by 4, and so on. You get this value. Now you sum it up. So what this sum is? This sum is actually summation of fi times xi minus m. And when you divide this by summation of fi's, you will get the mean deviation about median. Okay. So you have the sum, and summation of fi is actually n, which is 40. So you divide. So what we will have, mean deviation about median is equals to 502.78 by 40. When you calculate, it will come out to be 12.57. Okay. So you see all the steps after calculating the median. So how did we calculate the median? We calculated the median using this formula. Okay. Sorry. We calculated the median using this formula. When you calculate using the median using this formula, after that, everything is the same. Okay. I think this doesn't look good. Okay, no problem. I have written it here also. So when you calculate the median, you go on to the next slide and you see, you calculate absolute deviation, and then you calculate this summation of fi xi minus m by fi, and you will get the mean deviation. Okay. So I'll just summarize. I'm just trying to find a clean slide. Okay, right here we can do it. So mean deviation about any value a, it can be written as summation of fi times xi minus a by summation of fi. Now this a, calculating this a is important. So if a is the mean, so you have to calculate the mean of the data. Now it can be of two classes, continuous or discrete. For discrete, you know it is easy. You take the sum and divide it by the number of data. For continuous, you have to calculate the middle value. You see, we calculated the midpoint, right? When A is the median, we saw two continuous and number two discrete. For continuous case, we got this formula, m is equals to L plus n by 2 minus c by f into h. And for discrete, you know, just you arrange it in ascending order and you get the middle value. I know you should know how to calculate the median of discrete values. So for these two values, we generally calculate the mean deviation. You can have any other value. So suppose you have a question given the following data, calculate the mean deviation about the value 40. So this A you are given as 40, and the table which you will draw, you will take the absolute deviation from the value 40 and everything else will be the same. So you have to calculate each, the numerator and the denominator, and then you can easily calculate mean deviation about that value A. Okay, so what we have done, we have talked about mean deviation and we saw how continuous frequency distribution is tackled. We saw it can be calculated about the mean, it can be calculated about the median. We also saw how it can be calculated about mean deviation about any value A. So for median, we saw two methods. One is the, or we can write normal method or the usual method. The other is the step deviation method. So in exams, you will be given this term. Calculate the mean deviation of about the mean using step deviation method. So you should remember what you have to do. You have to get the assumed mean, the step length, and then calculate the mean and then proceed as further. So with this, we have done the discussion on mean deviation. Next, we will do how to calculate what is standard deviation, how to calculate standard deviation, and then we will go on to variance. And we'll understand what is variance and how variance is related to standard deviation. Okay. So I'll ask you to practice some problems. You take this example itself and you practice problems on this table. You draw the table. It is very easy to solve problems when you are doing it in tables, and you will get the same results. These results will be the same. And I'll also ask you to do it for the median, because the formula, you have to remember this formula to calculate the median. Okay. So thank you.